Okay. Thanks for coming to my talk, and I'm Asher Pembroke. This is actually the second time I've given a talk on NostrMail at btcplusplus. The first one was 3 years ago, and this was back before the age of AI, and we were coding everything in Docker containers. So it's a pleasure to be back, and now that this project has grown much larger than I initially thought it would be. My initial talk was just like, hey, here's this fun thing you can do with encryption, with using Nostr encryption, but over vanilla email rails. And so now it's an actual full-fledged app that you can get on the Zap Store. But what I want to talk about is what's the purpose of this project, and how does it fit into the wider space, especially at the Villains edition here. And I want to say that like signatures drive modern society. This is something we kind of forget, but like every single law that's passed, every time you sign interact with contracts with other people, you're always signing something, even though it's just a scribble. And there's a temptation, now that we're moving to digital signatures, to just hide all of the signatures from the user. And I have this hunch, or what I'm postulating here, is that this is a core UX problem that is what's holding back. We've lost the video. Yes? But my connection is kind of foobarred a bit. Okay. So I claim that this is actually one of the core things that's holding back user adoption of digital signatures, and I'll get more into that later. But so as I was building NostrMail, I got someone to help me play test it, and I was like, sorry, I haven't pushed up an update in a while. I got sidetracked trying to figure out how to make it newbie friendly. And he said, don't make it newbie friendly, laugh out loud, catering to the masses, always make great tools average. So I said, well, I just can't help myself here. I feel like something has to be done. And what I mean here is, so when we talk about PGP and email, like PGP has been around for like 35 years. Almost, well, you could say email started much earlier, but it really took off in the mid-90s. And to this day, like PGP is a success in some circles, mostly power users. Whereas email has grown to like billions of users, and every single business and individual has one, and it's sort of the de facto identity layer of the internet. So I was like puzzling over, what went wrong here. And I'm kind of putting this out here that a lot of it has to do with the wire format, the way email presents cryptographic information to the end user. So typically what happens is you have like some plain text that you're typing, goes through the PGP pipeline, and then out pops this like ASCII armored base 64 data. And to a computer scientist, this makes a whole lot of sense. But as we'll see, that really breaks kind of how this would work in a normal email situation. So email is basically very hostile to this type of encoding. So if you try to quote something, if you try to quote a signature, it just can't validate anymore. Also, email clients will like add spaces and change word wrapping and all sorts of stuff. Headers from the email can get stripped, so if you try to hide your data in the header, that may not survive forwarding chains. Reply and forward, often clients will just decrypt the data first before they send it on, which breaks the whole purpose of the encryption. Can't encrypt subject lines. Like that seems like it would be easy, but it's actually subtly difficult. So like Proton Mail can't even encrypt a subject line. And again, signatures can't be forwarded. And seems like, well, you know, who cares, right? But this is where DocuSign and Google enter the chat, like literally in your whole business flow. It's basically third-party providers that their authority is what you're relying on in their database to sort of check off on who signed what and when. So, so we have this great technology, but we're really not using it in everyday life. And then there's also a lot to be said about like how do you upgrade or update migrate from your PGP key if you lose it or change it, and that has a lot to do with identity living with the key instead of with, I don't know, what passes as a user. So I kind of realized I might be making the same mistake in how I was building NostrMail. So this is an email I sent to my brother who's playtesting it, and he saw, I thought he was going to get this and be like, yeah, finally a normal person. He's a smart guy, but like he's relatively not a computer scientist. And I thought he'd be like, yeah, finally privacy in Gmail. But this is what he said. it's like bro, your app is broken. There's like all this gobbledygook, and maybe we should fix that. So what I'm proposing here is that we make ciphertext human friendly. And my strategy is to go from ciphertext back to plain text. And the theory here is that like we can get, what we're after is like something that's user-friendly, authoritative, but also machine readable, and also passes spam filters and other kinds of filtering. And so the first thing that comes to mind as a Bitcoiner is like, why not use BIP39? This is what we use for mnemonics, and there's a reason we don't type in or we don't try to type in or transcribe base 64 or base 58 even for private keys. And I thought this was a really cool way of approaching the problem. So basically you have a word list. You design a word list that's like 48 words long, and then you try to make sure the words are easily distinguishable and has like 8 different rules. You can go through this. So I was like, okay, cool. We just use BIP39. And if you go to the BIP, you'll see all the languages that have been added: Czech and Chinese, English, French, Italian. And then my wife is German, and I thought, wait, where's the German? And here's the 3 separate PRs that were submitted to try to get German added. And you might think, oh, they just hate the Germans, like, but no, it's not just German. It's like, here's all of the Russian word list, Ukrainian, like, there were and this is again before the age of AI. So this is like 10 years ago. These were submitted. So it took a lot of work to build these word lists, and they were just sort of thrown out. So why were they rejected? They followed all the rules. They did all the work. But it turned out that this was like a problem that's sort of beyond the scope of Bitcoin itself. And the question of managing and dealing with these word lists is kind of beyond that scope. And I think it kind of turns out to be more of a language UX issue. So I decided we kind of need a separate project to just deal with this problem. And that's where Glossia comes from. Any Warhammer fans might know the reference there, but it comes from the root word glossolalia, which is speaking in tongues. And the idea is that you can go from, it has a bunch of word lists. You go from binary, encode it into, for example, this middle panel. Those are the payload words. So the word list is used to carry the data in payloads. And then you sprinkle in cover words to make it syntactically correct for the language you're targeting. So in this case, English. And it basically spits out Mad Libs. So it's a pretty simple tool. So like here, if we put in btcplusplus villains, it transcribes it into, these are BIP39 words. highlighted, and then these cover words. So the cover words can get stripped out in the decoding process. So if we switch from encoding to decoding, you'll see that we can recover the original content. So the whole point of a codec is that you don't lose information when you encode and then decode. So it is a little bit more complicated than that. The grammar system is based on Montague grammar, which is this typed lambda calculus thing. And in your word list, you actually have to like annotate whether it's a noun, verb, adjective, or whatever with different weights and yada, yada, yada. But the cool thing is that like that can all live in, can be debated about amongst the linguists. I wrote a Latin one that has 2 to the 15 words. So just for all practicality perspective, having 2 to the 15 words means you get 15 bits per word, and BIP 39 has 11 bits per word. So that means that a 12-word seed phrase you can represent with just 9 Latin words, which is kind of cool in and of itself. Okay, so how are we using this in NostrMail? I'll actually give a brief demo here. Yeah, I think we have some time. So this is like what it looks like when you're composing an email. You select a contact, has their email address, and their Nostr pub key. How they get that, I'll show that in a moment. You set up your Nostr settings, private key, yeah, it's a normal thing. But this is, the email setting is like, it's just using the normal email rails. So Gmail is the provider in this case. You have to set up an app password, but this is pretty standard for like Outlook style flow, and then relays. And then under this tab, there's Latin, I think, is the default, but you can change like which language you're using for body encryption versus signature versus like pub key representation. Set up your profile. Contacts can be private or public, which is handy if you don't want everyone knowing your contacts. But if the user, for example, this guy, if they have published their email address in their profile, which no clients do except NostrMail, then you can email that person clicking that button, and this will fill in their pub key, email address, and then you can type in like your subject that you want to encrypt and your body, hit the encrypt button, and now the subject line turns into these seemingly random words. We still have the ASCII armor, but in the ASCII armor is just plain text English, which is syntactically correct English, but it has no real semantics. You can preview before you, so like when you preview, if you click this lock icon, you can decrypt it, and it shows you what that looks like to the end user. You can preview this is like the raw version that goes over the wire. So you notice so we have the ASCII armor, the signature block is Latin, and then the prose block is English. Also shown here is a public key, and I'm kind of debating, but just making this an option whether you want to hide that too within the Glossia. And then the HTML is basically the part that non-NostrMail clients will just render this HTML, and it just looks like Latin. So this is what it looks like when you send, and then the receiver this is in their inbox. When they click on the signature, it expands, and then it shows that Latin Glossia here with a pub key. So you can do, the whole point of doing this, wrapping up soon, is that like now you can do things you couldn't do with like Proton Mail. Like you can reply to a message, you can include the previous message, and all the signatures just stack up at the bottom. So I call this concept chainmail, you know? So it's like, it's adds verification, but inline in a way that if a user just receives a message, they can forward it on to the next person that needs to validate. And this is what Gmail sees. So if you notice, I clicked on like the AI overview, and it says like, oh, this person sent a message containing random words and an unintelligible block of text. And it has a pub key in there. So this is all Google knows about this message, and which is, I think, pretty cool. That, like, whatever their AI tools are, there's some privacy restored. So other projects in this space I should mention is there's another NostrMail project that started up recently. They got OpenSats funding recently, so good for them. But their approach is very different. It introduces a new kind event within the Nostr relay system. So it's more like adding email to Nostr rather than adding Nostr to email. But it again has the same restrictions that ProtonMail uses. So like you can't get end-to-end with Gmail or Yahoo. Uses a trusted gateway similar to ProtonMail, so that assumes that once they receive an email from the normal world, you're trusting that they encrypt it and don't look at it. Doesn't have IMAP and so forth. So the future, so to make this more villainous, depending on whether you think this is good or bad, you can run a cashew mint behind an email server. But because cashew is just like, it's just text files, really, and you can include those as attachments. So why not use that for paying for your email? You can get around spam by just saying, like, attach a postage stamp with this email. So that would be pretty cool. Carbon copying, you could basically, the number of people you're copying is your anonymity set. So if you decrypt, if you're able to see it, then you can read it. But that leads to this idea of like onion routing and mixing amongst your peers and other people who they are downstream of. And then, of course, adding the kind 1301 event type into our NostrMail would let people receive messages from nostrmail.org users. But the other cool thing is, like, there's other ways of doing this outside of human text. Like, you can do it with music, images, and just pure mathematics. If you want to do it with prime numbers, you can. It's all just about following this idea of, like, do you have a list of symbols? Do you have a grammar that can compose those into things that are acceptable to humans? And that's important for, like, accessibility. So if you're blind, how do you even use, like, Bitcoin? I don't know. You have to trust someone, I guess, to deal with your keys. But you could imagine a wallet that's built around audio-based, like just, audio-based wallets, which would be cool. And then this is an experiment I'm doing with images, where my public key is the banner in my Twitter bio. So the idea is, like, you'd scan this instead of an ugly QR code. So we could probably get away from QR codes now that everyone has got a phone with a color reader, so that's cool. Yeah, that's about it. If there's time, I'll take questions. Okay. All right. Well, thank you.